Alright, if we're talking about related rates, we're talking about two different items that are changing at the same time, and their rates are related to each other. So an example here is air being pumped into a balloon, so the volume increases at a rate of 100 centimeters cubed per second. How fast is the radius increasing when the diameter is 50? Alright, well, we know the rate of change of the volume is 100. We want to know the rate of change of the radius. We know that the diameter is 50, so the radius is 25. We know the volume of a sphere is this. When we take the derivative, we get v prime, we get r prime, we get 3r squared here with a constant in front. Now you plug in everything that you know, and when you solve it for dr dt, you get 1 over 25 pi, or this number here. A ladder is resting against a wall and it's sliding away from the wall, and they want you to find the rate at which the top of the ladder is sliding down the wall versus given the rate of change of the bottom of the ladder is sliding away from the ground on the wall. So we know they give us 6 and 10, so we can figure out y is 8. So we got all three sides of our triangle here, and we know the rate of change of x is 4. So if we use Pythagoras and we take the derivative, we get 2x x prime plus 2y y prime equals 0. Plug in all the numbers you know and solve for y prime. So here's some strategies they talk about in the book. They say, read the problem carefully, draw a very good picture, introduce notation, pick variables wisely like v for volume, t for time. Relate typically one quantity to another. Sometimes you have to introduce two equations to solve for one. And then you differentiate both sides with respect to t. There is a warning here. A common error when you're a common error is to substitute the numerical information too early. This should be done only after you differentiate. In example 1, we dealt with general values of r until we finally substituted r equals 25 at the last step. If we had put 25 in earlier, we would have gotten the derivative of volume of 0, which is not true. So here they give you a water tank, a shape of an inverted circular cone, radius, base radius 2 meters and height 4 meters. The water level is 3 meters deep, and it's being pumped in at 2 cubic meters per minute. Find the rate at which the water level is increasing. So they want to know the rate of change of h. They give you the rate of change of v. They interestingly don't give you the rate of change of r. But if we use similar triangles, we can relate r is to h as 2 is to 4. Okay? And so then we can solve for r by multiplying both sides by h and reducing the 2 over 4 to 1/2. Now when you plug this in for r, you've got a formula that no longer has 3 variables, it only has 2. If you squared the h over 2, simplified it, and you got a formula in terms of only 2 variables. Alright, so now when we take the derivative of v, you get v prime, derivative of h, you get h prime, but you also get 3h squared with a constant in front. Plug in everything that you know and solve, and you get your answer there. Alright, two cars are traveling towards an intersection C. A is traveling this direction at 50 miles per hour. B is traveling this direction at 60 miles an hour. And they want to know how fast is the rate of change changing between the two cars. So they're asking the rate of change of z with respect to time. Well, they give you x prime and y prime, and they ask you to find z prime. They give you x here is 0.3 and y here is 0.4, so you can figure out by Pythagoras that z has to be 0.5. So now that you know 5 out of the 6, when you take the derivative, you get 2z z prime plus 2x x prime plus 2y y prime. Plug in everything you know and solve for z prime, and you get 78 miles per hour. Notice it's negative because the rate of change is decreasing. That's why it's a negative number there. A man walks on a straight path at a speed of 4 feet per second. A spotlight is located 20 feet from the wall, and the spotlight is kept on the man as he's walking along the wall. What is the rate at which the angle of the spotlight is changing? Well, we know that the rate at which the person is walking is the rate of change of x, or x prime, and that's 4. We know x is 15, we know y is 20, so we can figure out this third leg is 25 by Pythagoras. Now we can say tangent of 20, or x over 20, tangent theta equals x over 20. Multiply both sides by 20 and you get x equals 20 tangent. Now take the derivative, you get x prime equals 20 secant squared theta times theta prime. Okay, and now you can figure out what secant is by looking at your equation here, and you know it's 25 over 20, or 5 over 4. So you plug that into your equation, multiply it out, and solve for theta prime, and you get your answer there, and that's how fast the spotlight is rotating. If you look at question 3, each side of a square is increasing at a rate of 6 centimeters per second. At what rate is the area of the square increasing when the area of the square is 16? So if we know the area is 16, we know the side is 4, and we know the side length is increasing at 6. So area is side squared, so a prime equals 2s s prime. And you plug in the 2, the s, and the s prime, and you get your change in the area. A spherical ball is increasing at a rate, the radius of a spherical ball is increasing at a rate of 2 centimeters per minute. At what rate is the surface area increasing when the radius is 8? So we know r prime is 2, we know r is 8, we don't know s prime, the rate of change of the surface area. But we know the formula for the surface area of a sphere is 4 pi r squared. So you get s prime equals 4 pi 2r r prime. Plug in everything you know, and now you know what the rate of change of s is. A cylindrical tank has a radius 5. It's being filled with water at a rate of 3 cubic meters per minute. How fast is the height of the water increasing? Well, we know r is 5. We know the change in volume is 3. So you can plug in 5 for r, because that never changes, but h and v are going to be changing, and you're going to get related rates for those two. So derivative of v is just v prime, derivative of h is h prime, and you still have your constant out in front. Plug in everything you know and solve it for h prime. Number 9. Suppose 4x squared plus 9y squared equals 25, where x and y are functions of time. If y prime is 1/3 and x prime is, find x prime when x equals 2 and y equals 1. So you know y prime is 1/3, you don't know x prime, you know x is 2, y is 1. So you take your derivative of the original equation, and you get 8x x prime plus 18y y prime equals 0. And you plug in everything that you know, and you solve it for x prime. And you get your answer. Now they change it around a little bit. They say, well, what if x prime is 3 and we're looking for y prime, given x and y are -2 and +1? Well, it's the same formula. You're just plugging in different values and solving for y prime this time.